Yes, so we'll start, I guess. Hello, everyone. Welcome to Tinkering Bootcamp. This is week 2, session 2. In today's session, we will hope you are all doing well. In today's session, we will be going more in depth with the BLYNK app. BLYNK app is a IoT specific app. We use it for various applications and for controlling IoT devices such as Raspberry Pis, ESPs, and Arduino with the app on both iOS and Android devices. And we have a very brief overview of UART. So we'll start with the session now. Yes, so many of you asked last time that what is UART? So UART is Universal Asynchronous Receiver and Transmitter. UART is not a communication protocol like I2S or SPI or I2C. UART is in itself a physical circuit uh, built onto the circuit board, or it can itself be an individual IC built onto the uh, Yeah, so UART is itself in itself a physical circuit board built onto the audio is not audible. I am not on mute, the audio must be audible. Aniket, is the audio audible?
Yeah, audio is audible. Please continue.
Thanks. Yeah, so it is a physical circuit built onto the development board or whatever the board may be, the Raspberry Pi or Arduino or the ESP in our case. So it could be anything. It could be an individual IC in itself. UART was at first used for UART was I can't hear we are good. Select the microphone.
Am I audible well now? Hello?
Yes,
Okay, fine, great. So change my microphone from the headphones to the system. So this is an individual IC. It can or a circuit board integrated into the circuit itself. So these TX RX pins you guys asked about and UART. So these pins are actually the all of the most of the transmission is done and receiving is done by these pins. So I earlier talked that uh, we had three UART channels on the ESP32. So those were UART 0, UART 1 and UART 2. So UART 0 is these are the two pins for UART 0, RX 0 and RX 2 for UART 2. These are the two pins for RX 2 and RTX 2 UART 2. And as I mentioned earlier, all of the pins of the ESP32 are not exposed on all development boards. So this board that we had only 30 pins. It does not have it didn't have the these pins exposed, the RX1 and the TX1. So those chips are pins are not exposed in this development mode. So actually UART are two devices. UART are two devices such as this TX RX pins are built onto the both devices. So one is a master device and one is a slave device, but there is two-way communication in between. Then the TX is the transmitter and the RX is the receiver. So the information is transferred from the TX to the RX and vice versa for the second device. This is two-way communication between only two devices. There cannot be multiple devices. So what happens is, in the case of the Arduino or the ESP, the microcontroller unit sends some data to the UART device, the UART standalone UART circuit on the development board, or even in the case of Raspberry Pi, the microprocessor unit. So parallel data is fed into the UART. This data all the data comes simultaneously, and then the UART device converts this data into serial data. Parallel data comes simultaneously, and UART converts it into serial data. So it is transmitted over one channel. You can say line by line, like one word is spoken by 8 people at a time. Some word is spoken at by 8 people at a time, and then someone else converts it and says it as a sentence. So that's what is going on here. And then the UART2 device makes sure that there is no error in the transmission. The data was not changed during the transmission. It makes sure of that, and then it converts it from from serial data to parallel data. So it converts it to serial data. So we'll see more about the error checking mechanism. And so there are only two wires used, one from TX to RX and then from second device is TX to RX. The maximum speed is 1,15,200 baud. Baud is the data speed at which that data is transferred. It is usually 9,600 baud, but it can be up to 1,15,200 baud. Baud is actually bits per second. So it is asynchronous, as mentioned in the abbreviation itself. It does not require a clock in other communication protocols. A clock is required to synchronize both the devices. For example, in I2C, a clock is mentioned. So in this, there is no clock. The data is transferred over, and there is a start bit and an end bit, stop bit, a start bit and a stop bit. So the secondary receiving UART device knows that the bit started here and ended here. It takes that and it converts it to parallel data. There is serial transmission, yes, because there is only one lane for data transfer from one device to other, and then one lane from the another device to the first one. So there are only one master and slave. This can be only between two devices, not more than that. So yeah, so there are this is a typical packet of UART data packet. This is a start bit, stop bit, and parity bit. So parity bit is an error checking mechanism essentially. The data frame, so the start bit must exist and the stop bit must exist, but the parity bit is optional. But in most cases, we use the parity bit. When the parity bit is being used, there can be only 5. The data frame can be from 5 to 8 bits. But if the parity bit is not used, it can be extended to 9 bits. So 5 to 8 data bits for the parity case, and without the parity. So we will discuss more what is the parity. Aniket, admit the people in the meeting room, please. So 5 to 9 data bits can be used. So the start bit, usually the transmission line, the TX line is normally held at a high voltage level. It is high, and when the transfer is started for one bit for one clock cycle, the transmission line goes low, and the receiving UART device knows that a transmission has started and it starts its processing. So the data frame can be 5 to 8 bits long if parity is used. If no parity is used, it can be 9 bits long. Parity, we haven't discussed more about parity. Parity describes the evenness or the oddness of a number. So in essentially we use parity here for error detection if there is data changed in some way when the transmission is being done. So if we say that let's have a 5-bit data 5-bit data packet, and there are, suppose, 3 of those bits are ones and 2 of those bits are zero. So the receiving unit does what it does is it counts the number of ones in the data bits. So there are 3 in our case. So it checks with the parity bit. If the parity bit is 1, so 1 means odd parity and 0 means even parity. If the parity bit is 1 and there are 3, that is an odd number of ones in the data packet, then it knows that the data packet is errorless, and that's how it determines that there was no change during the transition of sphere of error, and the data has not changed while the transmission was going on. And it happens many times between these things. So UART, and there is a stop bit at the end. It goes from low voltage to high voltage for 2-bit durations. Like for 2 bits it is high. So that's what a stop bit does. It tells the receiver that the transmission has been stopped. So UART is used in Arduino and ESP and Raspberry Pi and other development boards, ESP8266 as well, for connecting them to modules such as the Bluetooth module. The Bluetooth module integrates Bluetooth. ESP does not require because it has inbuilt Bluetooth, but the Arduino and the Raspberry Pi can benefit from integrating Bluetooth. And then there can be an Ethernet module, a Wi-Fi module. These modules can be integrated into the microcontroller unit or the microprocessor unit using the UART interface. Also, a GPS module is connected with the RX module. The GPS module, as apparent by the name, does global positioning of the device. And a GSM module can also be connected with this same data transmission line of UART. So these devices are but we don't have to really worry about these transmission bits and how the data is being transmitted, because we do not go, this is all internal electronics. We do not really go this deep when developing for IoT applications. The libraries for in case of Bluetooth module HC05, the libraries take care of that. So we do not have to worry about the transmission of data and things as such in most cases. So the advantages are there is only uses 2 wires and there is no clock signal required. It is asynchronous, so no clock signal is required. So only 2 wires. If there was clock signal required, there would have been 3 wires. So has a parity bit to allow for error checking. That's the error checking mechanism we discussed earlier. The structure of the data packet can be changed from both sides, and it is well documented, widely used. It was earlier used in printers, like before the prevalence of USB. It was used for printers and scanners and all kinds of peripherals that we connect to computers. So it was a very heavy port. Like it was not as compact as the USB main or the USB-C we use these days. And then the disadvantage is size of the data frame is limited to maximum. In the most cases, we just take 8. Okay. in most cases we just do 8 bits of data transmission, but if we don't use the parity bit, but it is recommended to use the parity bit, and then only two way communication is possible between two devices. There cannot be multiple slave or multiple master system. Other protocols can be, but it is so prevalent and it is so easy to operate with that most devices are integrated, including the Arduino, the ESP32, ESP8266, and the Raspberry Pi, all the versions of the Raspberry Pi. The baud rate of each USB must be UART. So this is a thing while you cannot have one at 9,600 bauds and another at 1,15,200 bauds. The baud rate should be in 10% of each other for the functioning to work flawlessly in between the devices. So now we will be having some interesting demonstration for the BLYNK app, and we will also have participant interaction in between. If you haven't, you should download the BLYNK app in iOS or Android, so the session can go flawlessly. Aniket, you are ready? Take it away.
Yeah.
Okay.
Yeah. So we are. I'm ready. Yeah. So welcome again. Welcome again, guys. Hello, I'm Aniket Agarwal, one of the speaker of this Tinkering Bootcamp. So hope you enjoyed till now. Now we will having some basic intro about BLYNK app, and we will be getting to know how to use the BLYNK app, and then we will also be having some interesting demonstration in which we will doing some fun activities, and you will also be participating in that. So let me get started with first the intro for the BLYNK app. So yeah, so let me first get started with the BLYNK app. So am I audible and my screen is also visible? Please acknowledge somebody.
Yeah, go on.
Okay, so yeah, now getting started with BLYNK. So why to use BLYNK and what is this BLYNK? We are using it? So basically, it is one of the best known app for doing IoT things. Like if you want to have some of the data of your sensor in your mobile, you want to visualize, you have planted a system anywhere, and you want to visualize its data of the system, what the system is recording data. You want to visualize it in your mobile app, or you want to control that system via your mobile app. So this is the best known app we have for controlling a hardware system or displaying the data of sensors. Suppose you have a factory and you have some temperature sensors of near any machine. So you can see the temperatures of that machine in your mobile app, and when the temperature got rise above a maximum limit, you can see and just pause that machine from your home, from anywhere in the world. So this is the benefit of BLYNK app. So this is how BLYNK app works. So this is this side, right side, is basically the app version of BLYNK app, and this is a figure of how BLYNK app works on the left side. So basically you have given many widgets such as button, slider, timer, joystick, you have some displays also, and many more. When you scroll down in your app, you will see many more widgets here. Every widget you have to set some pins, and every widget you have to set some pins, and you have to set some name of that. If you want to look at your app attractive, then you have to set some names of that. So basically a BLYNK takes signals from your app, gives it to BLYNK server, which sends it to BLYNK libraries, and which basically you upload, which sends it to the code you uploaded in the BLYNK in your any of the module. It can be used in RPi, it can be used in Arduino with internet Ethernet sealed, or it can be used in any ESP32 node MCU, ESP8266 with Wi-Fi connection. Any mode you want with Wi-Fi, with wire, you can use it. The BLYNK server basically sends the data to that device, and it does the operation what you want. So you just not only do the operation in just like you just not do the operation within an Arduino, taking data from sensor and giving that data to the another thing connected to the Arduino. You can take it from your mobile and give it to something connected on your board, any of the board you want. So now we'll be seeing a live demo of how you do this. For that, let me share the screen. Okay. So yeah, so for that I will show you the Blink app first, so you can see the Blink app clearly. When you will open the Blink app, you can see that when you will open the Blink app, you can see that you will see such a screen. You can try it right now, and or you can first look at this and then we will let you try. So you can click on new project. You have to select whatever device you are using. So you can see that here are many number of devices, whatever is available. So you choose ESP32 dev board. You have to write your name of the project. So suppose you write the name as tinkering boot camp. So you write the name there, you choose the whatever theme you like. So let me create a project. So it shows the odd token was sent to Aniket Agarwal, this. Okay, so I will click okay. So now I'll tell you what the odd token is. But first see how you have to add widgets. So here you have, in the free version you have 1000 energy, so you can add any of the widgets here. So you can see there are many of the widgets here. You can add any of, but you have to add within the limit of 1000 energy, as there are some free version, there are some restriction. You can add your energy via this, but it requires money. So if you are doing some project, you can also do that. So yeah, I have added a button here. So let me take it in the middle, and then let me show you how to configure the button. So first I will write the name LED, then I have to choose the pin. So my pin is, as I used in the previous tutorial, 21. So this is 21st pin. I will switch it, I will keep the mode as switch, not as push. So because I had to use the LED in a switch mode, then I will write the label as off and on, just to be interactive with my app. It's not necessary to write the name or the thing. So now I will click play, but you can see that wasn't online yet. So your device, you don't have anything written in your device, so you just will see this, and nothing will happen if you do on and off here. So for that we have to write some code in Arduino IDE. So now let me open my Arduino IDE. So yeah, let me open the Arduino IDE. In this, first let me open new, close this. Okay, so first what you have to do is go to manage libraries, and in manage library, you every time you have to this updating occurs. But when this is finished, you have to type here blink, and the first ever library which you see. So yeah, the first library by Voldemir Szymanski, this you have to install. So I already installed it, or you can also go to the link which we have sent in your mail or the Telegram group. But this is a better way to install the library. So you can just directly install it from here. You can decrease the version 2, but why to do that? So you can just install, like in this you can install from here. So if you haven't installed this, there will be option right here to install the library. So you can install it from there. Now you have to just close this, and when you have installed, you have to go in examples. Here in bottom most you will see blink. In that you will see the board's Wi-Fi, and in that you will see ESP32. So you just have to click on this and close this. Okay, so this ESP32 Wi-Fi has been opened. These are all commented out, you can read this, but these are all meaningless. So now I will explain you. So this is just some simple codes of 10 lines at max. So now I will explain you what this lines mean. So this we are defining, just as we define in C++ something to something, we are defining here blink print to serial. We can also define blink print to any another thing, but why we are defining to serial, I will explain it later when I will run my code. But for now, let's move further. I am including Wi-Fi library, as I have to connect my node MCU to Wi-Fi. I'm also including Wi-Fi client, and also including one library, blink simple ESP32, which is the library for blink, which includes the blink functions in your code. So now here is some odd token is asking, and as you can remember, I told you that we have got an odd token in our mail. So if you haven't got, then you can also go to the settings and email all odd tokens. You can do this, but I already got it in my mail, so I will just let me. Yes, I will just paste that odd token here. So let me go to the odd token thing. So let me go to my email, and yeah, let me take this odd token. I will just copy this, and I will go in my Arduino IDE and paste it here. So this odd token basically is showing that yes, this Blink project is connected to this node MCU. This is basically for that. So now I will be entering my Wi-Fi name, as I have to connect some Wi-Fi to this node MCU. I will enter the Wi-Fi name 4567112. I will enter the password, and then just the serial.begin will begin the serial monitor. Blink.begin will begin the connection for with this auth ID, this SSID, and this password. There in this you can have some more things like cloud name or IP address name, but we writing these three is sufficient. So we will just write this three auth, SSID, and password. And now you can see that in void loop there is single line blink.run. So it gives the permission to Blink server to run the node MCU as the app suggesting it to run. So this line runs iteratively and gives the permission all the time to the Blink server to, yes, just keep the node MCU or ESP32 or whatever board you are using running as your app wants. So now I'll show you while uploading this to my Blink. So let me first, yeah. So as you can see that this is the code. So this is the code for that, and let me open the serial monitor here. So this is the serial monitor, and let me rotate it. This is the Blink app. So let me okay, so in Blink, yeah, I have created the button in Blink. So let me now open the camera, and you can see the connection as in the previous tutorial we have used. So now I will do again split screen. So open in split screen. So yeah, this okay. So yeah, here we are using the split screen. So now let me upload this code. So let me check the port. Yeah, port is there. So let me upload this code. This is the code we have just taken from the example. So just you have to write the auth token, SSID, and password. And while uploading, when it shows connecting, you have to just press this button for booting. So let me show you what happens. So let me just, yeah, wait for it. I can drag and drop the button here, as you can see. So yeah, it's compiling. Now it will upload. Um, so let's wait for a while. As you know that the ESP32 takes some times to upload. Sometimes the Arduino IDE also takes to compile for the first time a code runs. So yeah. Now I am pressing the button. Yeah, now boot happen. It is the code is uploading, writing at 100%. Yeah, the code has been written, and you can see that this has been printed. But where does this come from? I don't have written anything here to print in serial. I just have begin serial monitor, but I don't have written anything specifically to print. So where this things come from? So I'll tell you where this internal function calls the serial monitor, but it does not call serial monitor. It calls blink print. It calls blink print dot println to print the things in somewhere in the blink system. But if we define that to serial, it will print it also in our serial monitor. So you can see as the comment is here, comment this out to disable prints and save space. So you can comment this out, you can check while by commenting this out that this will not print, so you can check it out on your own. Now I'll show you that yes, the let me again split the screen. So yeah, you can see that as now I will run, you can see this is showing, this is not showing that error thing in the yellow there. This data is wrong for many times. This don't show online rate, but our system is online, as you can see, connected like this. So because but you can verify that whether here is a yellow symbol or not. If there is a yellow symbol, then you can see that your device is not connected, and if there is not, then you can be sure that your device is connected. And when now I click on in my mobile, the device is on, and when I click off in my mobile, the device is off. So on and off, we can do this. So I hope some of you have followed this example with me. So does anyone of here done the same thing right now in your BLYNK app? Does any one of you have created such project right now when I am showing the tutorial? If anyone, just unmute your mic and tell me so that I can take him as a volunteer, because I need someone as a volunteer to show a demo. Anyone? Uh, Hello, anyone? So just volunteer. Somebody just volunteer. I will see that I will make you the project right now, and I will show you the demo, live demo. So anyone, please just unmute your mic and volunteer and say out your name if you want to volunteer. No, Rahul, you don't have to worry about this. I'm just showing you a tutorial, and I will help you out for this thing right now. So just okay, Rahul, can you be the volunteer? Just unmute your mic and speak. Hello, Rahul. Okay, so if none of you are appearing for volunteer, Gagan, will you volunteer? Okay, 1 minute. Okay, you are asking for 1 minute. Okay, so yeah, take your time.
Just
Yes.
register onto the app and then create a new project. Open your mail. You will get this code into the mail, the authorization token, and then paste that code into the chat so that the Aniket can put that into the code and upload the code onto the ESP.
Yeah, just make like this. Just make a new project. Just get the token from your email, and just set a button like this from here, add button. So you will add a button like this, and then just configure is at digital and 21. Just and change it to switch mode. Don't keep it in push mode. Change it to switch mode. And okay, I will rotate it. Maybe it's hard to visualize from there like that. Okay, so you can unmute your mic and tell Rahul what position are you lying and what step are you doing. Okay, till then let me show you something.
Hello.
So, okay, Rahul.
Hello.
Yeah. Yes. We
Yeah.
are listening
Yeah.
you.
I was connecting my headphone. Sorry for that.
Okay.
Uh,
Okay. Yeah. So now, yeah,
so
can you open your BLYNK app?
yeah, I have opened it. So what I have to do?
You have created new project?
Yeah, I have started a create new project. Project name.
Yeah.
So what I have to
Yeah.
type?
Any name you want, trial, anything you want. Just
Okay.
type out the name.
Yeah, done.
Then just your OR token will be sent to your email which you have connected.
ESP8266.
No. You have to select ESP32.
Select ESP32.
So see on the screen, you have to select this ESP32 just
Done.
above ESP.
Done.
Done. Okay, so now you will see a odd token sent to your mobile, to your Gmail.
Okay. 1 minute. I will check in my mail.
Yeah. Just check in your mail. So rest of you can see that this is like button. Okay, so you can take whatever pin you want in the, your pin is from 1 to 39, so you can take whatever pin you want in your board. But as Gagan explained in previous session, that some pins are better, some pins are ranked from worst to best to worst for output and input mode, so you have to take care for that. So that's why I've connected to 21, as it seems good for me. It works good for me to just for use the LED in analog, also in digital, any mode you want. So you can try it out on your own node MCU, which pin works best for you. If you are using multiple functions, then you have to choose many pins. So yeah, yeah, Rahul, are you ready? Are
I
you
didn't
have
got
you
any mail.
you
I
have
created the project,
okay,
but
so
I didn't got any mail.
go inside the project, and in the settings bar, just click on email all. And
1 minute. Settings. So
yeah, someone else can also try if you want. If you want, you can just follow the same steps, and you can give me your or token right in the chat box.
Acha, wait. You can
Okay,
copy the copy.
Tejal has
Tejal has used that.
okay,
Log
Tejal,
out.
you have created. Please unmute your mic and say that. Did you have created this button like this?
Yeah, I've created one.
You have created like in pin 21, digital pin 21. You have created the button.
Yes.
Hello.
Yes.
Okay. So cool. Then I will upload your code, your auth token now in my this, and let me open the my camera to let you visualize. So now I will, yeah, I will let it boot. Yeah, so it's booting. So Tejal, can you show your mobile phone? And yeah, this seems connected. So Tejal, can you now play the click the play button on your mobile phone and just show it on the screen while turn on your video.
Yeah, sure. Just a second.
Yeah.
The button is initially off, right?
Yeah, you have to keep the button in switch mode, not in push mode. Yeah, so you can see. Tejal, can you show on your mobile? Please turn on your camera. Yeah, so you can see that as as Tejal clicks on the button, here the LED is on, and it is no wired connection from anywhere in the world. Like she is at her home, I am in my home, and she can from there access to this LED while she is connecting to the BLYNK. So yeah, you can see that. Okay, thank you Tejal for this. Any else, if you want to try, we will take your auth token too
Okay.
after this session. We will be
Oh,
here,
like
and we will take your auth token too. But for now, I will move further with my tutorials. We are having some more fun activities, so we will take some other auth token that time. So yeah, now let me, yeah, so now let me uh, okay, I have to let it down. Yeah, okay, so we have seen the button thing. Now, but okay, so I will show one thing. You can see that in the button, the pins, here are some virtual pins. So what are virtual pins? The pin can't be virtual, it must have to be real somewhere in the world. So what's the meaning of a virtual pin? It's meaningless. So but this is not like that. So I will show you what the virtual pins means, and what are they, why to use, where to use. So yeah, what are they? So they are basically some virtual pins that exist in the Blink app to send and receive signal from ESP32 board. But we can send and receive signal from real pins, just like we did in our previous example. So why to use them? So because that pins allow us to send and receive signals in any form. In digital pins or in we are just using digital pins and button, we can only send and receive signals in the form of 1 and 0. But if you want some analog things, you don't have any button types for that. If you want to use some if you want to send some text via your mobile app to the node MCU or whatever board you are using, you just have no any pins that takes the string or takes the float. The pins just take the information as 1 0. So for that we use virtual pins, and we have some functions defined in the Blink library, which we write in Arduino IDE to take the data from whatever we are writing in the virtual pin, or whatever we have to write in the virtual pin via our node MCU. So as you can see, some Blink functions, some Blink widgets don't have any real pins. So like we will show you some example that yes, this widget has don't have any real pins, so we have to use virtual pin there. So now we will be using some functions in Arduino IDE. So I will be showing you blink write, blink read. Blink write is basically for writing some of data in node MCU from whatever you have written in your mobile. So you click on in button while that button is. So these functions are only for virtual pins, first of all. So suppose you define a button in virtual mode, and then you click on. So you have written something in that pin. So blink write will, then the blink write function with that pin will be called, and then you have to just take the data and do whatever you want to do. They are also blink read to give the data to your virtual pin, to your any widgets connected to virtual pin in your Blink app. There are also timer functions which lets you run a function time at any time interval. And as you can see that in our void loop, let me show you that in our void loop I have just written only here blink run. So you cannot call any function at any time interval, because only blink run is running. So in that case, blink provides a feature called timer to just so that to just call it at a equal time interval. So we will be talking about this later, and these are three basic ones function which we will looking into, but there are many more widgets and functions to look into, like bridge, joystick. You can have your joystick in your mobile, you can have a GPS stream, you can have a email widget, you can have a LCD screen or whatever thing. You can have temperature display, time display, anything you want. You can try this by all yourself. Just you have to buy a ESP32 or any of the board you want to connect to Blink app. And the Blink app is full free for up to 1000 energy, and you have to just try it by yourself for fun. This is a real cool fun. So now I'll be showing you another live demo with virtual pins. So for that, let me so we are using a virtual pin. So first let's set here virtual pin. So let's set the pin to v1. Okay, so v1. Now let's change it as LED. Now this is just for look, make your app look good. I will change it to switch mode. and you can see that v1 type of this button has been said. I can drag and drop it anywhere in the middle. So yeah, by okay, so by selecting it we can also increase its size, but in this case we don't want to, but in case of slider we want to increase some size to be able to use it properly. So I will show you that. But first of all, how to take the data. So like if I play, if I keep it on, it will just go to a virtual pin. So how to send it to any real LED pin? So I will show you right here. So let me create a variable int LED equals to 21st pin I have used. So I have to remove D and write just only 21. I have to set the pin mode here as LED comma output. So yeah, I have written it here, and I just have to write a function. So I am showing you live how to write the function blink right. So you have to write everything in capital blink right, and then you have to declare the pins, virtual pin which you are using for blink right. So yeah, I am using v1, and now I have written, now I have, in just this I have to write take a value that this will give. So this will give any integer as 0 or 1 in this case, because it is either high or either low. So I will store this in led value variable, and then I will take value. So how to take value? It's very simple. Use param dot as int. This is the syntax. Use param dot as int. So this is the simple syntax. Param dot as int for int. Param dot as str for string. Param dot as float for float. So this is a very simple syntax. Now you just have to do one thing. You just have to digital write. So you just have to write the value whatever you got in your LED. So I will be writing here LED, and I will be writing the value LED value, whatever the value you got. So yeah, so now you can see LED value I have written. So this, whenever I give any function, any input here, the blink dot run will call this function blink dot write with for v1 which we have defined, and it will take the value and give it to LED. But we have to define the pin mode as output here. Why to do so? But because in the previous example we didn't do that. We just have we just have declared blink dot run, and we just don't have declared any pin mode, because blink dot run automatically declares whatever real pins you are using in your app. In the blink dot run, it automatically declares it as pin mode output, but it don't declares it when you use any virtual pin. So you have to for real pins you have to define them here via yourself. So now I'll be uploading this code. First I have to change the auth token here. So let me again take my auth token instead of that. So let me take this auth token, and let me paste it down here. Yeah. So now I will be uploading my code. Okay, let me turn on my camera, and yeah, so in camera you can see, okay, sorry, uh, I am booting this. So open in split screen view. So yeah, both these are ready. So yeah, I have uploaded this, and let me play this now. Okay, this is showing some error, and this is also not showing that thing. So just wait for a second. Maybe my hotspot has been turned off. No, it's on. So let me again upload it and see why it's not, why blink.begin.auth is not running. So yeah, let Yeah, so connecting to Aniket, connected, terminal bootcamp connected. Now you will play it. You can see no error there. And as you on it, you are on it. So let me show you that this function is actually calling by writing here a serial print ln led value. So whenever this function will call, serial print will printed on the serial monitor. So this will make sure that how many times this function is calling in one input case. So I will show you that yes, this function is actually been called every time whenever you write something in virtual pin. So yeah. Mm, okay, so I'm loading. So now, yeah, connecting to internet, connected. Now whenever I turn it on, you can see one has been written. I turn it off, zero has been written. So this function is actually been called every time. You can see that. Okay, so you can play it with this. I will not take any of your volunteer for this experiment, and it is pretty much similar than previous one. But now I am going to show you one more demonstration for actually what is this virtual function we are using. We can use that this function as in our like our previous tutorial too. We can, without using this function, we can perform the same action. So we are using this? So for that, let me show you that why it is so important. So I will pause it and I will turn the screen. So let me delete this, and now let me add another thing called slider. So I am adding a slider. I am taking it in the middle and I am uh, making it full screen. You can increase the size like this. So again, any volunteer, I want to volunteering at the same time. So can you, anyone can please just raise your hand or just can type in the chat box for if they want to volunteer. Just type in the chat box if anyone wants to volunteer. So because I will let him do the tutorial this time because some time problem. So please anyone just volunteer. I will show you how to do, and I will you will be doing it with me. So don't give any odd token. Just raise your hand or type in the chat box that you want to volunteer. So, okay, so let's take someone from the previous thing. So, Mudit, do you want to volunteer in this? Or Rahul, do you means if you are ready now? Okay, so Rahul, okay, so let's take Rahul this time. So Rahul, just you have created the project now.
Yeah,
Just
yeah,
yeah, you have created the project. So just delete everything in previously in your project and add a slider just like this.
yeah.
And also paste your auth token here so that I can copy it.
I have already tested. The
Okay, so
auth token will
yeah,
remain same.
yeah. You are using the same project now.
Yeah.
Okay,
Yes.
so I will paste this auth token now here, and okay, so I will paste this auth token now here. So now the SSID and password is same. LED is 21, and I have to use it. I have to write some analog thing. So I
And
have
can
to
check the
take
odd
the
token once, the double apostrophe at the end.
yeah,
The code.
yeah.
Yes. Okay. Fine.
Uh, so I will print the LED value, but this time we are taking a variable. So you can see that in this slider, you can see that, okay, let me show you by configuring this. Rahul, please do it simultaneously with me. I am showing you that
Yeah.
you have to add the slider like
I have
this.
taken a slider.
Yeah, so give it a full screen mode. Just increase its size so that you can do it properly, slide it properly, and then
Yeah, yeah. I
click
have
on
increased it.
this and write here LED if you want, and then use virtual pin V1. So use virtual pin V1 and this will take your value from 0 to 1023. Don't use this circle thing here. I will tell you that in another session what that means, but for now just use the straight line thing.
Okay, 1 minute.
And here decimal value just keep it as single hash. Don't change it. Send on release and show value on and on.
So virtual pin, which virtual pin I have to use?
You have to use V1.
V1. Okay.
So as you can see that we have set it up our LED, and when we slide this, this value changes from 0 to 1023. But our value in here changes only from 0 to 255 in the analog write. So I will first change it to analog write and write here LED value by 4. So I will take a LED value in between 0 to 1023, print it, and then divide it by 4 to give into my LED. Just I have to change it like this. But you cannot do this with a button because it does not provide any analog pins. It cannot provide any analog pins. It just provides 0 to 1, 1 to 0 thing. So you cannot do it with that. So Rahul, have you set up your whole thing?
Yeah, I have set it up.
Okay, so now I will verify it, but you will see that it will show some error, and I will explain you what that is. So yeah, here analog write was not declared in this scope, but how can it be possible? Because we are using analog write from our very first session. But as you remember that you are using it for Arduino, in the board of Arduino, in the board of ESP32 or ESP8266, we have to define analog write. We have to use a library analog write. So for that you just have to go in manage libraries and just click on here. Let it update. Okay, so now you have to write here analog write, and you will see that analog write ESP32. I have already installed it. You have to install it by Aeropix, and you have to include it here. So has include an analog write dot h. You have to include this, and now when you will verify this, you can see that it will verify correctly. So yeah, everything has been set it up perfectly. So now it will verify. let, let us give it some time. So it's compiling. I will okay, so done compiling. I will upload this now. For uploading, it will again compile. I just want to show you the error. That's why I just only verified it earlier. So yeah, now I will also rotate my screen, and okay, so I will boot it. Did can in my camera you can see this thing. Okay, this is a thing. Yeah. So connected. Okay, Rahul, can you show your mobile screen and can you slide that
I
slider?
can just slide how to show my mobile screen because I'm holding the
Okay,
mobile.
you are connected from mobile only.
Yeah,
Okay, so okay, just slide it. Just slide it
yeah.
by
I have slided. Started sliding.
no,
You
just
can
slide and
see
release
screen
your
share,
hand.
right? Rahul, you can
Okay.
screen share.
So just slide it in the middle somewhere around 100, 200 and stop. So you can see the light intensity is decreasing and here it is printing. So and
So it's
also
217.
okay, yeah, you can see that the same value has been printing here. So if you slide it to max, just slide it to max and
Yeah,
release your hand. Release. Okay, so
yeah.
you can
Release.
see the LED is at the maximum. So Blink server just not only connects in nearby, it connects everywhere in the world. So you can use it, and Rahul there can just change this LED thing right here. So just Rahul slide it down to 0.
Yeah.
But you have to release your hand for after sliding. You can't just see like whenever you are sliding in that thing. Maybe there's an option, but for now we are just doing this. Okay, so now thanks Rahul for this tutorial, for this demos, for doing the demonstration with us. So now I will be showing just a quick one more tutorial which is also pretty much interesting. So okay, now I want another volunteer in this, because okay, I will just want another volunteer so that many of you can try at the same time. So any volunteer, just paste your odd token here. Okay, Mudit, yeah, okay, so let's take Mudit this time, and let me just paste your odd token this time here, and we will, so yeah, so now I want to, Mudit, just do the
Yes,
things
yes.
I am doing, just do the things which I am doing with
Okay.
me. So yeah, you can see that I want to add a terminal. I want to show you terminal, how terminal works. So just add a terminal, Mudit, and maybe you can increase its size if you want. Just add a terminal, and on terminal just in here write chat, and in here write a new line, whatever you want to write here you can write, but in here do yes to add a new line every time, and then select the same V1 pin. Select the same V1 pin. So now I will show you that just do this settings,
Yes.
Mudit. Have you done?
Yes. I done.
Okay. So I will define here a string now, as Mudit will be writing some string from his keyboard. So I will define a string. I will take a string here, coming. I will string which is coming. I will write it as string as str. I have to use this time now param dot as str. Then I will print that coming variable, so that it will show on my screen whatever the thing Mudit is writing, the message, it will be shown on the screen, serial monitor screen. Now I will do what? I will define string. I will define another string going as serial dot print ln, sorry for that, serial dot read, not print. We have to read something from serial monitor which I have to send to Mudit, but the serial monitor in the starting will be blank, so it will just send a blank, null, no string. It will send no string because it will be blank. So I have to write here something in while loop, just like while going is equals blank. So while going is blank, keep on taking going from serial read, and as you write something in serial monitor, it will then change going to non-null string, and it will then exit the word while loop, and then I want to send something to Mudit. So I will write just here blink dot virtual write. As I am writing in a virtual pin, I will write here blink virtual write. So I will write here blink virtual write. Okay. Wait a second. I will write here blink virtual write. Yeah, that's the correct syntax. Blink virtual write, and I will write. So now I'm not taking data from anything, from any earlier defined and virtual pin. Means here I can write the data into any of the virtual pins. So I have to define the pin in which I am writing. So I will write here v1 comma, I will write here blink dot virtual write in v1 comma, what I have to write is going. So this will send the same message which I have written here to Mudit. So now I am going to upload it. So yeah, analog I don't need it, but let it be here. I have written the odd token for Mudit, and I don't need a LED too. So but let me upload this. It's no harm in extra something. So Mudit, have you done the settings now in everything?
Yes, yes.
Okay, so wait. Okay, so here is some error because serial.read reads in int. So I have to write serial.read string for this. And I have to write serial.read string for this. Now when I will okay, while okay, sorry for that. While is in small. So you have to take care for that basic syntax in this, because this is not to come with any intelligence. So autocorrect or so you what's the correct syntax, so you have to check it in every time you compile. So yeah, now it's compiling. Now I will boot my code. I don't have to show the camera because no LED is using here. So yeah, but now you can see that this is connected. So invalid auth token. Mudit, your auth token, please resend it on the
Okay.
please just resend it the chat. Okay, so the here is also a space in the starting. Was it?
What?
Is there a space in the starting, or it starts with M?
No, it start with M.
There is no space.
No, no space.
Okay, so I will upload it. I think I have uploaded the same, but there is a space. I think that's why it's not working.
I
Okay, so yeah, let me upload this one now. Did so I have to boot. Let's see what it shows. This time. Let's hope this time this works. So invalid auth token. Mudit, your auth token is somehow invalid. Maybe you just go into your app and just email it once again.
okay. Wait.
Let me just see with a space. Maybe I missed it out. Okay, so KRG, have you done the setup? I will use your auth token then. KRG, can you please speak?
Yeah, I have done.
Okay, so I will use your auth token instead. Okay, so now I will upload this and let's see. Yeah. So yeah, we have been connected, ready, ping. So please type something.
Okay.
Please send me some message.
Okay, how do I type here?
What?
In
Have you
terminal, I have to type something, right?
Yes, in terminal. Just like here, you have to play this and then you have to
Okay,
type
play
something.
first. Okay,
Yeah.
play first. Then, okay. So,
Okay, so yeah, you have written
yeah,
hello there. You can see it
yeah,
on the in my screen. So I will write
yeah.
hi. Have you got the message hi?
-1 I got.
Okay, so just send the message again. Actually, there is something initial in the serial monitor. That's why you got -1. But just send the message again.
I
Now,
sent hi. Okay.
okay, what you got?
I got hi. Yes, yeah.
Okay, so now send something else.
Okay.
so something else. Okay,
Yeah.
so okay, so now I'll write this is awesome. I will write this is awesome. Did you get this is awesome?
It's again -1. I don't know.
Okay, okay, maybe. So there are some data in the serial monitor initially. So okay, so that's why it sends -1 and -1. But okay, you can use it another way. So like you can okay. So if you will send something now, you will get that data. That you will get this is awesome types data. Send something just ABC something. Send it here.
Okay.
So you will get this is awesome types of data. Did you?
Yeah, this is awesome. I got. Yeah.
Okay. So basically there is something initial in serial dot read. Okay. So let me do it. Any. Let me just give a or statement and. Let me also restrict -1 from giving. So I will again upload this. So this is used for or statement. So yeah. So yeah, this let it compile. Just yeah, it is compiling. So let's try again, Mudit. Just wait for it to upload and just wait for it to connect. Yeah, it's connecting. So just click on means just type me something.
Okay. It's saying it's disconnected.
You have given okay.
Yeah. Okay. Yeah.
Okay, so now let me write something. How's the session going? Did you get this? How's the session going?
Yeah. I just got it.
So okay. So as you can see that we can
But
just
before
chat
that,
it.
there is 72 written here.
70.
72.
What?
72. How's this session going? It's not how's.
So can you show on your mobile screen what are you getting?
How do I share my screen? Just
Say,
by.
okay. So you have to share your screen for that. Okay. So just share your screen.
No, I'm using laptop and mobile
Okay.
separate.
So just turn on your video. Just turn on your video and
Okay.
show on the mobile.
I don't know if it will be visible or not. It's very.
Just
It's
try.
not. I think it's not visible, right?
Okay. I can't see it. Yeah.
Yeah.
So okay, but as you can see that we can chat over this means you have to just change some line
Yeah.
of code according to C++ which you have studied, and you can chat among this. You can chat via this. So this is basic blink write function which we use in different ways. In that we can insert something virtual write which sends data to your means you are getting some data na because we have written here virtual write. So it is sending that data to you. So this is this, and you can also take via this, but main motive of this is you take some data, you may reply to that, but you give that data to some of the circuitorial part or some of the mechanical hardware. So this is why blink write is used. You can control your hardware via this. So now let me move further. So yeah, let me move further. Time's up. Sorry guys. So we are prepared more things for you, but due to the time restriction we will be continuing till this in this session, but don't worry, we will be continuing from here in the next session, where we look upon rest of the function I have told you, blink, read, and timer. We will also see those functions. And today I'm also going to share the references for blink, write, blink, everything. Means I'll be sharing, let me show you, I'll be sharing this link which has all the examples of every widgets and getting started. So you can see all the examples here. I will be sharing that. And I will also be in next session showing you the tutorial for one of the most interesting thing, that is called voice assistant. So this time you are clicking a button to turn on the light. The next session you will be able to just speak from your home, and this LED right here in front of me will turn on. So this will make your childhood dream come true. When you watch the cartoons and you see that, oh, this magic is happening, you will be able to do that in the next session. So please come and attend the next session. It is also going to be very interesting, just like this. Now I'll be passing over to Vedant, which will be taking a quiz he prepared for you guys. So Vedant, hand over to you.
Hello, guys. It's really nice to talk to you guys again. Hope this session was really nice for you. We have tried to keep it a little bit interactive, and seeing so many odd tokens in the chat box was really overwhelming. The next session will be more interesting, even more than this. So be prepared for that. We'll be taking a quiz now, but remember, this quiz will not be used for grading. It is just for attendance purposes and to know how much you have grasped from the session. We'll also be having a feedback form after the quiz. Do fill it out too. It will also be used for attendance purposes. So I have sent a link in the chat box. Uh, Join the quiz. I'll be starting the quiz in a minute.
Also, we will be sharing a feedback form right now, but fill the feedback form after the quiz whenever you complete the quiz. So Gagan, also give the feedback form right now. And if any of you wants to have your Blink app connected to with this MCU, you can just wait after the session. I will be here. I will be taking your tokens if you want.
Do join the quiz first before filling out the feedback form. After you are done with the quiz, then fill out the Google form. But remember to fill that out because it is used for attendance purposes.
And it also helps us to see what we can do better in the next session.
Is anyone yet to join the quiz, or should I start the quiz?
Start if everyone is
Okay, I'll be starting the quiz.
So guys, who all ever have done with the quiz can fill the feedback form here in the chat box.
Uh,
Is everyone done with the quiz? I have to show one thing which I done wrong. Student has pointed out in the chat box. I will show it to all of
Wait
you.
for a
So
minute, Aniket.
okay, okay.
Some of
let
them are still giving answers.
okay. Let me wait for 1 more minute.
Yes, then you can start. Okay, I'll be ending the quiz now.
Yeah.
Aniket, you can take over.
Yeah. So let me show my screen. Yeah, so one of the student Vipin has pointed correctly that yeah, because some wrong error is showing because I just only have done read string here and not here. So when I do the read string here also, then the data will be correct. So that's why the data is not coming accurately. It's coming 72 or else. So I don't have to write this thing. I just have to write this, and that's why the error is happening. So yeah, but don't worry. I will be sharing this code and all other references. Don't worry, I will be sharing this code and all other references, video tutorials for you, and also in the next session I will be taking this forward. So just go through that and the video recording once again if you have any problem. And you can also ask doubts in the Telegram group if you have any later, or if you have any now, you can ask right now too. Make sure you fill the feedback form, and just if you have any questions you can ask that right now. If you want to try your blink app you can try now. So yeah, just fill out the feedback form, and the session is now over. But if you have any questions and or you want to try the blink app, you can stay.